Hello and welcome. In this unit, we will be talking about how to solve quadratic inequalities. And there are a few steps. Number one side needs to be 0. Second, need to factor and solve for x. Or whatever variable was used. Third, put the solutions on a number line. And fourth, find where it makes the inequality correct. In other words, or we accomplish this by making a sign chart. So if we had an inequality like this, x minus 3 times x plus 2, giving us a simple example where it's already factored. Let's say this is greater than or equal to 0. So since this is greater or equal, greater than 0, focus on that part of it. Greater than 0 means that it is positive. Okay, so we've got here x equals 3. Would make this 0. If I put 3 minus 3, that's 0. Or x equals negative 2 because negative 2 plus 2 equals 0. And so I can graph these two things on a number line. I put negative 2 off to the left and positive 3 to the right. And then I consider negative 2 to be like the center part, like the 0. And so everything to the left of negative 2 would be negative. And then everything to the right would be positive. If I consider 3 then to be the 0, the center part, everything to the left of 3 would be negative, so negative, negative, and to the right would be positive. And so then I think negative times negative would be positive, and negative times positive would be negative, and a positive times a positive would be positive. And so my solution set, because it can be equal, then we use a closed circle at negative 2 and also at 3. And then the solution set has to go according to what we have. And we've got, since greater than means positive, then we go where this thing would be positive, which is off to the right. I'm sorry, off to the left. And then also off to the right. And interval notation, that's negative infinity to -2, the bracket, and then we use this U symbol, union. That means it joins with the solution set off to the right with +3. We use a bracket at both 3 and at -2 to show that it can be equal to -2 and also equal to 3. Then it continues off to positive infinity on the right. Let's look at some other examples here. Example 1, we've got x squared plus x minus 2. So it's already equal or greater than 0. One side's 0 on the right, so we don't need to do that. And then we want to factor. So we put our little graphic organizer here, and we put -2 up here and +1 down here, and we're looking for two numbers that multiply to -2 that combine to +1. So I put 2 times 1, because 2 times 1 is 2. 1 has to be positive, 1 has to be negative, but since this number down here is positive, we want the positive on the 2 and negative on the 1. So we can factor this and say x times x, and then we put in the numbers that we've got here, +2 and -1. And this has to be less than 0. So less than 0 means that this thing is negative. And so x plus 2, if here we've got x is equal to -2, because -2 plus 2 would be 0, or x equals 1, because if I put in 1 minus 1, that would be 0 as well. So we've found our numbers. The next step is to go over here and graph them on a number line. So here's -2. The other thing that's noteworthy here is that because it's strictly less than 0, it's not less than or equal to. This time we're going to use an open circle. So we go over here, and here's 0, and here's 1. And again, we use the open circle there. Now we make our sign array, our sign chart. So if we consider that -2 is like our 0 point, to the left of -2 would be negative, and to the right would be positive for both of those spaces. And then if we consider it 1 would be our 0 point, then to the left of that would be negative, and to the right would be positive. And then we want to go through and figure out, okay, so negative times negative is positive in this space. Negative times positive would be negative here, and positive times positive would be also positive. And we go back and think, okay, we were looking for numbers that were less than 0. Less than 0 is negative. So this is our interval with our solutions. So we would shade in between them. And then in interval notation, we would put comma, -2, this time a comma instead of a bracket because it cannot be equal to -2, but it can approach -2, comma, 1, and then another parenthesis, and that would be our solution set there. In this next example, we're going to practice factoring when our leading coefficient is something other than 1, in this case 3. So you recall in those circumstances we take a times c, or 3 times 5, which would be 15. and then our b term, which is negative 16. So we're looking for two numbers that multiply to 15 that combine to give us negative 16. So to get a positive result, you have to multiply either two positives or two negatives. But since the bottom number is negative 16, the two numbers should both be negative. So we'll put negative 1 times negative 15, which would multiply to give positive 15, negative times negative positive. But then a negative 1 plus a negative 15 is negative 16. We then put it inside our box, which we could have done in the last example, but we didn't have to. And we put 3x squared in the top right. We put plus 5, our constant term, in the bottom right. And then negative 16x, we use the numbers that we found. So let's put negative x here and negative 15x. Negative x would be negative 1. So then we factor each row and each column by greatest common factor. The greatest common factor between 3x squared and minus x would be x. And then x times 3x would give us 3x squared, x times 3x. And then 3x times minus 5 would give us negative 15x. And negative 5 times negative 1 would give us positive 5. Plus negative 1 times x is negative x. So it works all the way around. So our factors then are 3x minus 1 from these factors along the top, and then x minus 5 from the one on the side. And these are less than or equal to 0. Since it's equal to, we'll have a closed dots at our intersections. So then we can take each one of these two factors and set them equal to 0. 3x minus 1 equals 0, or x minus 5 equals 0. 3x minus 1, if I add 1 to both sides, then I get 3x equals 1, and then divide by 3. So x equals 1/3 is one of our solutions for the equal part. And then adding 5 to both sides over here gives us x is equal to 5. So with these two solutions, we come over here and we graph them on a number line. We'll say this one is 5. Like I said, because it's less than or equal to 0, then we can put equal to with dots, closed dots, instead of open circles. And that would be at 5. I'm going to count backwards. 4, 3, 2, 1, 0. And 1/3 we'll label right there. And then we say, let's go back and analyze this. Less than or equal to 0 means that if it's less than 0, then it's negative. So then we're going to come over here and figure out where is this thing negative. So 1/3 is our 0 mark. To the left of that would be negative, and then positive to the right. And if 5 is our 0 mark, then to the left of it would be negative, and to the right would be positive. And then we say negative times a negative would be positive in this section. Positive times negative would be negative in this section. And then positive times positive would be positive over here in this section. And so a negative result is what we're looking for. So our solution set is in between these two, because that's where this is negative. So let's see, in interval notation we would write bracket 1/3, comma, and it goes all the way over to 5, which would also be a bracket. And that would be our solution set in interval notation. If we look at our last example we're going to do together before you start working on your own, we've got x squared minus 4x is less than or equal to -3. And this is an example where we see, oh, we need this to be 0. And so for it to be 0, we're going to add 3 to both sides, and that would give us x squared minus 4x plus 3 is less than or equal to 0. And now we want to factor this. So we say x here, x. Two numbers that multiplied to 3 would be 3 and 1, but add to -4. So in order for that to be true, it has to be -1 and -3. Well, -1 times -3 would be +3, but those two numbers combine to give a -4. So then our values that we're looking for, here is x equals 1, and here is x equals 3. So we can come over and before we move past here, this part right here, less than or equal to 0, once again tells us that less than 0 means that it's negative. So we're going to graph 1 and 3. We're going to use a closed dot because it can be equal. There's 1, 2, 3. We make our sign array, our sign chart. To the left of -1 would be negative. In between, and then to the right would be positive and positive. And then if 3 is our central number, to the left of it would be negative, 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 and then positive to the right. So then a negative times a negative is positive, and a positive times a negative is negative, and a positive times a positive is positive. And because we want it to be negative, this is where it's negative, is in between 1 and 3. So we shade that in there. And then we say our interval notation, we go to 1, starts at 1 on the left, and then goes to 3 on the right. Brackets in both places to show that they are equal. And that's how we do it. Now you need to go and practice some on your own. Let me know if you need help.